Binary search interview questions for backend developers. Introduction. Binary search is an efficient searching algorithm used to find a target value in a sorted search space. Backend developers often learn binary search for interviews because it appears in queries, sorted lists, database-like search problems, optimization problems, pagination logic, log search, time-based search, capacity planning problems, system design style algorithm questions. A common learning topic is, how can backend developers master binary search interview questions? This guide explains binary search basics, Java implementation, common patterns, sorted array search, lower bound, upper bound, rotated sorted array, first and last occurrence, binary search on answer, real backend examples, mistakes, interview questions, practice roadmap. This is one of the best practical guides for backend developers preparing for coding interviews. Simple definition. Binary search is a search technique that repeatedly cuts the search space in half. Simple idea. Sorted array. 1, 3, 5, 7, 9, 11, 15. Target equals 9. Check middle. If target is bigger, search right half. If target is smaller, search left half. Time complexity. O log n. This is much faster than linear search. O(n). Why backend developers learn binary search? Backend developers use binary search thinking in H-sorted data search, CX logs and timestamps, database index concepts, API pagination boundaries, retry backoff tuning, rate limit threshold search, capacity planning, performance optimization problems, interview coding rounds. Example backend style problem. Given sorted log timestamps, find the first log after 10:30 a.m. This is a binary search problem. Binary search versus linear search. Feature: linear search, binary search. Data requirement: any data, sorted, searchable data. Time complexity: O of n, O of log n. Search style: 1 by 1, divide by half. Best for small, unsorted data, large sorted data. Interview importance: basic, very important. Example: 1 million records. Linear search may check 1 million items. Binary search checks around 20 items. Core requirement: binary search usually needs sorted data or a monotonic condition. Monotonic means false, 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 true, 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 or dot. True, 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 false, false, false. Example: can ship packages within D days. Capacity equals 1 means false. Capacity equals 2 means false. Capacity equals 5 means true. Capacity equals 10 means true. This can be solved using binary search on answer. Basic binary search pattern. Public int binary search. Int nums, int target. Int left equals 0. Int right equals nums length minus 1. While left equals right. Int mid equals left plus right minus left divided by 2. If nums mid equals target, return mid. If nums mid is less than target, else right equals mid minus 1. Return -1. Important. Int mid equals left plus right minus left divided by 2. Better than. Int mid equals left plus right by 2. Because it avoids integer overflow. Binary search visualization array. 2, 4, 6, 8, 10, 12, 14. Target. Left equals 0, right equals 6, mid equals 3, means nums 3 equals 8. 12, 8. Search right half. Left equals 4, right equals 6, mid equals 5, means nums 5 equals 12. Found binary search time complexity. Each step cuts the search space in half. N, 2, N4, N8. Time complexity. O of log n. Space complexity. O1. For iterative binary search. Binary search patterns. Important patterns. Pattern use case. Exact search. Find target index. First occurrence. Find first target. Last occurrence. Find last target. Lower bound. First value greater than or equal to target. Upper bound. First value greater than target. Rotated array search. Sorted array rotated. Binary search on answer. Find minimum maximum valid answer. Peak search. Find local peak. Search, sorted matrix pattern 1, exact search. Problem. Find target in sorted array. Example. Nums equals 1, 3, 5, 7, 9. Target equals 7, answer equals 3. Java. Public int, search, int nums, int target. Int left equals 0. Int right equals nums length minus 1, while left equals right. Int mid equals left plus right minus left 2. If nums mid equals target, return mid. If nums mid might greater than target, left equals mid plus 1, return minus 1. Pattern 2, first occurrence. Problem. Find first index of target in sorted array with duplicates. Example. Nums equals 1, 2, 2, 2, 3, 4. Target equals 2, answer equals 1. Java. Public int, first occurrence, int nums, int target. Int left equals 0. Int right equals nums.length minus 1. Int result equals -1. While left equals right. Int mid equals left plus right minus left divided by 2. If nums mid equals target, result equals mid, right equals mid minus 1. Else if nums mid equals target, left equals mid plus 1. Else right equals mid minus 1. Return result. Key idea. When target is found, save result and continue searching left. Pattern 3, last occurrence. Problem. Find last index of target in sorted array with duplicates. Example. Nums equals 1, 2, 2, 2, 3, 4. Target equals 2, answer equals 3. Java. Public int, last occurrence int nums, int target. Int left equals 0. Int right equals nums.length minus 1. Int result equals minus 1. While left equals right. Int mid equals left plus right minus left slash 2. If nums mid equals target, result equals mid, left equals mid plus 1. Else if nums mid less than target, left equals mid plus 1. Else right equals mid minus 1. Return result. Key idea. When target is found, save result and continue searching right. Pattern 4, count occurrences. Problem. Count how many times target appears in sorted array. Example. Nums equals 1, 2, 2, 2, 3, 4. Target equals 2. First equals 1. Last equals 3. Count equals last minus first plus 1 equals 3. Java. Public int, count occurrences, int nums, int target. Int first equals first occurrence, nums target. If first equals -1, return 0. Int last equals last occurrence, nums target. Return last minus first plus 1. Pattern 5. Lower bound means first index where value is greater than or equal to target. First, nums I equals target. Example. Nums equals the list 1, 3, 5, 7, 9. Target equals 6. Answer equals 3, nums 3 equals 7. Java. Public int, lower bound, int I nums, int target. Int left equals 0. Int right equals nums.length, while left right. Int mid equals left plus right minus left times 2. If nums mid equals target, left equals mid plus 1, else right equals mid. Return left. Important. Search range is left right. right equals nums.length. Pattern 6, upper bound. Upper bound means first index where value is greater than target. First nums I beating target. Example, nums equals 13579. Target equals 7. Answer equals 4. Nums 4 equals 9. Java. Public int. Upper bound int nums int target. Int left equals 0. Int right equals nums length. While left equals right. Int mid equals left plus right minus left over 2. If nums mid equals target, left equals mid plus 1. Else right equals mid. Return left. Lower bound versus upper bound concept meaning. Lower bound, first index with value greater than our target. Upper bound, first index with value greater than target. Example, nums equals 1, 2, 2, 2. Target equals 2. Lower bound equals 1. Upper bound equals 4. Count equals 4 minus 1 equals 3. Pattern 7, search insert position. Problem. Find index where target exists or should be inserted. Example, nums equals 1, 3, 5, 6. Target equals 5. Answer equals 2. Target equals 2. Answer equals 1. Target equals 7. Answer equals 4. This is lower bound. Java. Public int search insert. Int nums int target. Return lower bound nums target. Pattern 8. Search in rotated sorted array. Problem. Sorted array is rotated. Find target. Example, nums equals 4, 5, 6, 7, 0, 1, 2. Target equals 0. Answer equals 4. Java. Public int search rotated. Int nums int target. Int left equals 0. Int right equals nums dot length minus 1. While left equals right. Int mid equals left plus right minus left 2. If nums mid equals target, return mid. If nums left equals nums mid. If nums left is equal to target and target nums mid, right is mid minus 1. Else, left is mid plus 1. Else, if nums mid below target and target target, left equals mid plus 1. Else right equals mid minus 1. Return -1. Key idea. At least one half is always sorted. Pattern 9. Find minimum in rotated sorted array. Problem. Find minimum element in rotated sorted array. Example. Nums equals 4, 5, 6, 7, 0, 1, 2. Answer equals 0. Java. Public int find min int nums. Int left equals 0. Int right equals nums.length minus 1. While left equals right, 0. Int mid equals left plus right minus left divided by 2. If nums mid greater than nums right, left equals mid plus 1. Else, right equals mid. Return nums left. Frac. Pattern 10. Find peak element. Problem. Find an index where nums I is greater than its neighbor. Example. Nums equals 1, 2, 3, 1. Answer equals 2. Java. Public int find peak element. Int nums. Int left equals 0. Int right equals nums.length.1. While left equals right, int mid equals left plus right minus left time. If nums mid less than nums mid plus 1, left equals mid plus 1, else right equals mid. Return left. Key idea. Move toward the rising slope. Pattern 11. Search 2D matrix. Problem. Matrix rows are sorted. First element of each row is greater than last element of previous row. Search target. Example. Matrix equals 1, 3, 5, 7, 9, 11, 13, 15, 17. Target equals 9. answer equals true. Java. Public Boolean search matrix, int apostrophe matrix, int target, int rows equals matrix.length, int cols equals matrix.length, int left equals 0, int right equals rows times cols minus 1, while left equals right, int mid equals left plus right minus left over 2, int row equals mid divided by cols, int col equals mid percent cols, int value equals matrix row col. If value equals target, return true. If value equals target, left equals mid plus 1. Else, right equals mid minus 1. Return false. Key idea. Treat 2D matrix as virtual 1D sorted array. Pattern 12. Binary search on answer. This is very important for interviews. Used when answer is not an index, but a value. Examples. Curse, minimum capacity, minimum speed, minimum days, maximum minimum value, smallest valid threshold, search space, possible answer range. Condition, can this answer work? Binary search on answer template, public int binary search answer, int left, int right, while left less than right, int mid equals left plus right minus left over 2. If can do mid, right equals mid, else left equals mid plus 1, return left. Key idea. If mid works, try smaller. If mid does not work, try bigger. Example, Koko Eating Bananas. Problem. Find minimum eating speed to finish all piles within H hours. Java. Public int min eating speed int piles int H. Int left equals 1, int right equals 0. 4. Int pile piles, right equals mathmax right pile, while left equals right. Int mid equals left plus right minus left divided by 2. If can finish piles H, mid, right equals mid, else left equals mid plus 1. Return left. Private Boolean can finish int piles, int H, int speed. Long hours equals 0. For int pile piles, hours plus 2, pile plus speed minus 1 over speed. Return hours equals H, tapa. Example, ship packages within D days. Problem. Find minimum ship capacity to ship all packages within D days. Search range. Left equals max package weight. Right equals total weight. Java. Public int ship within days, int da weights, int days. Int left equals 0, int right equals 0. 4. Int weight equals weights, left equals mathmax left weight, while left and right. Int mid equals left plus right minus left divided by 2. If can ship weights days mid, right equals mid, else left equals mid plus 1. Return left. Private Boolean can ship int weights, int days, int capacity. Int required days equals 1. Int current load equals 0. 4. Int weight its if current load plus weight over capacity required days plus current load equals 0. Current load plus equals weight. Return required days equals days. Backend real-world example 1. Search logs by timestamp. Problem. Given sorted logs by timestamp, find first log at or after target time. This is lower bound. Java. Public int first log at or after long log timestamps long target time. Int left equals 0. Int right equals timestamps.length. While left greater than right. Int mid equals left plus right minus left 2. If timestamps mid equals target time. Left equals mid plus 1. Else right equals mid. Return left. Use cases. 1. Monitoring logs. 2. Audit events. transaction history, time series data, debugging production incidents. Backend real-world example 2, API pagination boundary. Problem: find the first record greater than a cursor ID. This is binary search if local sorted list is available. Public int, first record after cursor. Long IDs, long cursor ID. Int left equals 0. Int right equals IDS length. While left equals right. Int mid equals left plus right minus left divided by 2. If IDS mid plus cursor ID, comma left equals mid plus 1, else right equals mid. Return left. Backend real-world example 3, capacity planning. Problem: find minimum number of worker threads needed to process jobs within 1 hour. This is binary search on answer. Search: workers equals 1 to max workers. Condition: can process all jobs within target time. Pattern: public int min workers, int job times, int max allowed time. Int left equals 1. Int right equals job times dot length. While left equals right, int mid equals left plus right minus left 2. If can process job times mid max allowed time, right is mid, else left is mid plus 1. Return left. Common binary search interview questions. Easy questions: binary search, insert position, first bad version, guess number, higher or lower, square root of x, valid perfect square. Medium questions: find first and last position of element, search in rotated sorted array, find minimum in rotated sorted array. Element search, a 2D matrix. Koko Eating Bananas, capacity to ship packages within D days, find smallest letter greater than target, single element in sorted array. Advanced questions: median of 2 sorted arrays, split array, largest sum, minimize maximum distance, aggressive cows, allocate books, maximum minimum distance. Smallest paired distance. Question 1, binary search. Problem: given sorted array nums and target, return target index or -1. Key pattern: exact binary search. O log n. Question 2, search insert position. Problem: return index if target exists, otherwise return index where it should be inserted. Key pattern: lower bound. Java. Public int, search insert, int nums, int target. Return lower bound, nums target. Question 3, first and last position. Problem: find start and end index of target in sorted array. Example: nums equals 5, 7, 7, 8, 8, 10. Target equals 8. Answer equals 3, 4. Java. Public int, search range, int nums, int target. Int first equals first occurrence, nums target. Int last equals last occurrence, nums target. Return new int, first, last. Question 4, square root x. Problem: return integer square root of x. Example: x equals 8, answer equals 2. Java. Public int my squared, int x. Int left equals 0. Int right equals x. Int result equals 0. While left equals right. Int mid equals left plus right minus left 2. Long square equals long mid times mid. If square equals x, result equals mid, left equals mid plus 1, else right equals mid minus 1. Return result. Important: long square equals long mid times mid. Prevents overflow. Question 5, first bad version. Problem: given versions 1 to n, find first bad version. Pattern: false, 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 true, true, true. Java. Public int, first bad version, int n. Int left equals 1. Int right equals n. While left, right. Int mid equals left plus right minus left over 2. If is bad version mid. Right equals mid. Else left equals mid plus 1. Return left. Question 6. Search rotated sorted array. Pattern. One half is sorted. Decide which half can contain target. Important interview explanation. Even though the array is rotated, at every step either left half or right half is sorted. Use that sorted half to decide where target can be. Question 7. Find minimum in rotated array. Pattern. Compare nums mid with nums right. If nums mid equals nums right, minimum is on right side. Else, minimum is at mid or left side. Question 8. Koko eating bananas. Pattern. Binary search on minimum speed. Search range. 1 to max pile. Condition. Can finish within H hours. Question 9. Ship packages. Pattern. Pattern. Binary search on minimum capacity. Search range. Max weight to total weight. Condition. Can ship within days? Question 10. Split array largest sum. Problem. Split array into k subarrays. Minimize the largest subarray sum. Search range. Left equals max number. Right equals total sum. Condition. Can split into less than or equal to k subarrays with max sum less than or equal to mid. Java. Public int split array int nums int k. Int left equals 0. Int right equals 0. For int num nums, left equals math max left num, right plus equals num. While left and right dot int mid equals left plus right minus left divided by 2. If can split nums k mid, right equals mid, else left equals mid plus 1. Return left. Private boolean can split int ab nums, int k, int max sum, int count equals 1, int current sum equals 0. For int num nums, if current sum plus num greater than max sum, count plus current sum equals 0. Current sum plus equals num. Return count equal to k. How to identify binary search problems. Look for keywords. Sorted array, first occurrence, last occurrence, minimum possible, maximum possible, smallest value that satisfies, largest value that satisfies, search space, monotonic condition, rotated sorted array, peak, threshold, capacity, speed, days. If problem says, find minimum x such that condition is true. Think. Binary search on answer. Binary search decision guide. Ask. 1. Is the data sorted? 2. Is the answer space ordered? 3. Is there a monotonic condition? 4. Can I eliminate half of the search space each time? If yes, binary search may work. Common mistakes. 1. Infinite loop. Bad. While left equals right, int mid equals left plus right 2. Left equals mid. Problem. Left may not move. Better. Left equals mid plus 1. Or carefully use. Mid equals left plus right minus left plus 1 times 2. 2. Overflow in mid calculation. Bad. Int mid equals left plus right over 2. Better. Int mid equals left plus right minus left 2. 2 common styles. Style 1. While left equals right. Used for exact search. Style 2. While left equals right. Used for lower bound or binary search on answer. Do not mix carelessly. 4. Forgetting duplicates. If array has duplicates, exact binary search may return any occurrence. Use first last occurrence pattern if needed. 5. Wrong boundary update. For lower bound, if nums mid equals target, left equals mid plus 1, else right equals mid. For upper bound, if nums mid equals target, left equals mid plus 1, else right equals mid. Small difference, big impact. 6. Not proving monotonic condition. Binary search on answer only works when condition is monotonic. Example: capacity increases means shipping becomes easier. That is monotonic. Best practices. Use left plus right minus left 2. Decide search range clearly. Choose loop condition carefully. Test small arrays. Test empty arrays. Test one element. Test duplicates. Test target smaller than all. Test target greater than all. Explain monotonic condition. Use long when multiplication sum can overflow. Helper method for can-do problems. Check. Practice lower bound and upper bound deeply. Backend developer explanation style. In interviews, explain like this. Because the array is sorted, I can compare the target with the middle element and eliminate half of the search space each time. That gives O log n time. For answer search, the answer space is monotonic. If capacity X works, then any larger capacity also works. So I can binary search the minimum working capacity. This explanation is very important. Binary search templates. Template 1. Exact search. While left equals right, int mid equals left plus right minus left times if nums mid equals target, return mid. Else if nums mid is less than target, left equals mid plus 1. Else right equals mid minus 1. Template 2. Lower bound. While left equals right, int mid equals left plus right minus left. If nums mid is less than target, left equals mid plus 1, else right equals mid. Template 3. Binary search on answer. While left equals right, int mid equals left plus right minus left. If can do mid, right equals mid, else left equals mid plus 1. Practice roadmap. Beginner level. Practice. C. Binary search. Search insert position. First bad version. Square root x. Lower bound, upper bound. Goal. Understand boundaries and loop conditions. Intermediate level. Practice. First and last occurrence. Rotated sorted array. Find minimum rotated array. Peak element. Search 2D matrix. Single element in sorted array. Goal. Recognize variations of sorted search. Advanced level. Practice. Corpse. Koko Eating Bananas. Ship packages within D days. Split array largest sum. Allocate books. Aggressive cows. Median of 2 sorted arrays. Goal. Master binary search on answer. 30-day learning plan week 1. Binary search basics. Learn. Exact binary search. Loop conditions. Mid calculation. Sorted array search. Edge cases. Practice. Binary search search. Insert position. Square root of x. Week 2. Bounds and duplicates. Learn. First occurrence. Last occurrence. Lower bound. Upper bound. Count occurrences. Practice. Find first and last position. Count target occurrences. Smallest letter greater than target. Week 3. Modified binary search. Learn. Kirk, rotated arrays. Peak element. 2D matrix search. Single element search. Practice. Search. Rotated sorted array. Find minimum in rotated array. Find peak element. Search 2D matrix. Week 4. Binary search on answer. Learn. Monotonic condition. Minimum valid answer. Maximum valid answer. Helper can-do function. Practice. Koko Eating Bananas. Ship packages within D days. Split array largest sum. Aggressive cows. Allocate books. Interview questions and short answers. 1. What is binary search? Binary search is an algorithm that searches a sorted search space by repeatedly dividing it in half. 2. What is the time complexity? O log n. 3. Why does binary search require sorted data? Because we decide which half to discard by comparing the middle value with the target. 4. Why use left plus the quantity right minus left, all divided by 2? To avoid integer overflow when left plus right becomes too large. 5. What is lower bound? Lower bound is the first index where value is greater than or equal to target. 6. What is upper bound? Upper bound is the first index where value is greater than target. 7. How do you find first occurrence? When target is found, store the index and continue searching left. 8. How do you find last occurrence? When target is found, store the index and continue searching right. 9. What is binary search on answer? It means binary searching a possible answer range instead of an array index. 10. When can you use binary search on answer? When the condition is monotonic. Example: if capacity 10 works, capacity 11 also works. Real backend use cases. Binary search thinking appears in finding first log after timestamp, finding record after cursor, searching sorted audit events, capacity threshold search, performance tuning threshold, index lookup concepts, time series range queries, partition boundary search, feature rollout threshold analysis. Example: find first API latency sample above 500 milliseconds in sorted metrics. This is lower bound style search. Final summary. Binary search is one of the most important coding interview topics for backend developers. Important concepts include exact search, first occurrence, last occurrence, lower bound, upper bound, rotated sorted array, peak element, 2D matrix search, binary search on answer, monotonic condition, Java implementation, edge cases. Backend developers already understand sorted data, logs, timestamps, indexes, pagination, thresholds, capacity planning. This makes binary search easier to connect with real-world backend problems. Key idea: binary search is not only about arrays, it is about reducing any sorted or monotonic search space by half until the answer is found.